Okay, here's the recording in progress. Go back to share the screen. All right, so I'm going to knock off 2.5 and maybe start reviewing for the test. Okay, tomorrow's a buffer day, doesn't mean it's a holiday. I'll just go back and review, and if anybody else has a real question, you can bring that up. And maybe in the most extreme case, if I get done with everything and there are no questions, I might start sneaking in some of the next chapter, but we'll see how it goes. Okay, so next exam is Friday. You've already seen one exam, so all the exams are similar in nature. So you submit this homework. I must get at least 70% of the homework, but again, that's really a joke because I do a great percentage of the homework anyway, in which case all you got to do is copy it. You get one formula sheet, one cheat sheet, 8.5 by 11, both sides, put anything you want, formulas, sample problems, and you can use a calculator. And this is the one day where you have to show up to the Zoom call. Okay, so everything else is optional. So, you know, optional, but you must show up here. Optional, but you must show up here, and so on, right? And now that you've gone through one, you know the spiel by now. So have your camera on, true background, no go to gate bridge, no outer space or anything like that. True background, keep yourself muted. If you have any questions, put them in the chat. And then I'll close the class at a normal stopping time of 10 o'clock. Then you have until 10:05 to take pictures, click. Or if you have a scanner, scan it. And then you have until 10:30 to submit the homework. But if you want to submit the homework early, anytime after tomorrow's class, that should be fine. Okay. All right, so I'm going to try to knock off as many of the rest of 2.5 as we have to do, and then that'll be it. Okay, so I was mentioning last time for 19 through 23, find the indicated value. So it doesn't say f of blah, blah, blah. It says f inverse of blah, blah, blah. So you're not going to plug in for x. So what else am I going to plug in for? I'm going to plug in for y. And you say, well, I don't see any y. Well, just change f of x to y. Make it y equals blah, 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 y equals. And then instead of plugging in for x, which is what you would do if it said f of x, right? But if it says f inverse of whatever, you plug it in for y. So I'll show you a couple of those. It's not really that hard. So 19 says f of x equals x plus 1. Okay, so they want f inverse of 2. All right, so I plug in 2 for y. 2 equals x plus 1. And then that's easy, just subtract 1, so x equals 1. Okay, and then 23, f of x is 1 over x. Find f inverse of 2. So again, don't plug in 2 here. You plug in 2 for y. So where's y? Well, here's y. So 2 equals 1 over x. Okay, multiply both sides by x. Include the fraction 2x equals 1. So x equals 1/2. Right? So that's all there is to it. And in case you're wondering, you may notice, hey, that's the same thing as I would have gotten if I directly plugged in 2 to the original. That's correct. Okay, that's because this 1 over x happens to be a function which is its own inverse. The inverse of 1 over x is 1 over x. Okay? One way to think of it is a reciprocal. 1 over x means reciprocal. If you take the reciprocal of a reciprocal, you're back to where you started from, right? Like if I say, what's the reciprocal of 3/2? You say 2/3, right? Now take the reciprocal again. Oh, you're back to where you started from, 3/2. Okay? Or if I say start off with 7, what's the reciprocal? 1/7. Do it again. What's the reciprocal of 1/7? Well, 7. So here's a function which is its own inverse. That's allowed. Okay, how do I find the inverse? And then graph f and f inverse on the same coordinate axes. Okay, so how do I find the inverse? So 25, y equals 2x minus 1. So first thing I'm going to do is switch around x and y. Everywhere you see y, put x. Everywhere you see x, put y. So x equals 2y minus 1. And now I just simply solve for y. So add 1, divide by 2. So y equals x plus 1 over 2, which is my f inverse of x. So here's f. This is the undo function, x plus 1 over 2. It always brings you back to where you started from. Okay, just for fun, let's try it. Suppose I plug in 2 here. What do I get when I plug in 2? 2 times 2 is 4. 4 minus 1 is 3, right? Okay, 3. Now take that 3 and plug it into the inverse. 3 plus 1 is 4. 4 divided by 2 is 2. That's what I started off with originally. Okay, so this is like the G when I was doing the fog and the Goff, F circle G and G circle F. In this particular case, the F inverse is the G. And when you do F of F inverse or F inverse of F, you always get back the original X. All right, now it says graph it. Well, this has a slope of 2 and a y-intercept of -1. So I put a dot at -1. And then I go over 1 up 2 because the slope is 2. So 0, -1, 1, 1, connect them. Now, I could graph this by doing y equals mx plus b. It's a little bit clumsy. It'd be 1/2 x plus a half. I think it's a lot easier to just switch around x and y's, which means 0, -1 becomes -1, 0. Put a dot there. 1, 1. What do you get when you switch around 1, 1? Well, it stays 1, 1. And then I just connect those since I know it's linear. So there's my F inverse. Okay. All right, the problem's finished. There actually is a reflection property. Okay, I'm not holding you responsible for it, but there is a reflection property. A function and its inverse is a reflection across the line y equals x. Okay, so I'll just state it. F and F inverse are reflections. Remember we talked about x-axis symmetry and y-axis symmetry and origin symmetry. F and F inverse are reflections across the line y equals x. So if you reflect across y equals x, then you get the other point. And that kind of makes sense because if you have 0, -1, right? You put the mirror here, the mirror image would just be -1, 0. And that also means 1, 1 is on the line y equals x, right? So if it's already on the line, that makes sense. If you switch around 1, 1, you're still at 1, 1. Okay. But otherwise, the line y equals x is the mirror image reflection of one to the other. Okay. Jumping all the way to 37. I'll come back to other ones. Show that the given function is not 1-to-1 and determine a subset of the domain of the function which is 1-to-1, then find its inverse on restricted domain. Okay, f of x equals absolute value of 2 minus x. First of all, I decided to change it to absolute value of x minus 2. These are the same. Since 2 minus x and x minus 2 are opposites of each other, the opposite of this is this. Well, their absolute values are equal, right? If two things are opposites, absolute values are equal. Like 5 and -5, they're opposites. They both have the same absolute value, 5. Or if I say pi and -pi, they have the same absolute value, pi. So I'd rather work with this. Okay, so this thing, well, that's my absolute value function. Whoops. That's my absolute value function shifted 2 to the right. So I get my V shape. Bottom is 0, 0. Now the bottom is 2, 0. So absolute value of x minus 2 is right there, this v. And you know it's not one-to-one. But they say, if you restrict the domain, can I throw out a lot of the graph so that it becomes one-to-one? The answer is yes. So this v is the original shape. The reason why I put it as a dotted line, if I decided to throw this out, right? Throw this out and only take this part here, now it's a one-to-one function. So this is a one-to-one function. So sometimes you can get a one-to-one function if you're willing to restrict the domain. And they asked me to graph the inverse. So how do I graph the inverse? Well, I'll just take some key points. 2, 0, 3, 1, 4, 2. Flip them around. 2, 0, 0, 2. 3, 1, 1, 3. 4, 2, 2, 4. And there we go. So here's F inverse. Again, F inverse is F with that -1 floating up there. So this one's interesting. The inverse function turns out to be parallel to the original. And again, if you stop and think about it, that makes sense. If you think of the reflection property that I just talked about, F and F inverse are reflections across the line, y equals x. I go like that, right? Then one is the mirror image of the other across the line y equals x. So that actually does make sense. Okay, 35 is kind of like that too, where they give me a restricted domain. F of x equals x squared plus 1, x is greater than or equal to 0. So maybe just some background. Do you recall the shape of x squared plus 1? It's a parabola, U shape, opening up. Now, if I just look at x squared, that's my standard parabola vertex of the origin, right? And then what's the effect of the plus 1? Take the parabola and move it up 1 unit. But then it says x is greater than or equal to 0. Okay, so here we are. So the full graph of x squared plus 1 is, I don't want to do it, just kind of, okay, that's x squared plus 1, right? Parabola. That parabola is not one-to-one. It does not pass the horizontal line test. However, if they tell me x is greater than or equal to 0, right? So this part is not really there, right? If I only look at this, now it is one-to-one. Which means I can find and graph its inverse. How do I do that? Well, I just pick some key points. Plug in 0, you get 1. 0, 1. Sorry, you can't read that. It says 0, 1. 0, 1. Plug in 1. 2. Plug in 2. 5. 0, 1, 1, 2, 2, 5. How about the inverse? Switch them around. 0, 1, 1, 0. 1, 2, 2, 1. 2, 5, 5, 2. And it goes like that. So here's my F inverse. And again, they are reflections of each other across the line y equals x. Right? So if I put a mirror right here, the mirror image of this one is this one and vice versa. All right, so that's it for that one. Another one I'm going to go back and show you is 2.535. Oh yeah, I already did that. what is the equation of the inverse? So what's the equation? Y equals x squared plus 1. So to find the equation of the inverse, switch around x and y. X equals y squared plus 1. Solve for y. Subtract 1. X minus 1 equals y squared. Do my square root property, square root, square root. So y equals f inverse of x is radical x minus 1. So it's my square root function shifted 1 over to the right. And there it is. And that does seem very reasonable. What we had over there, right? Okay, now I don't think the problem asks for it, but let me go ahead just for practice about domain and range. Here's the original function. What is the domain set of x values? Well, it looks like it can go 0 all the way out. So bracket 0 to infinity. What's the range? So the lowest y value was 1 and it shoots up. So range 1 to infinity. And so the red graph, domain bracket 0 infinity, range bracket 1 to infinity. How about f inverse? Okay, so for this one, that's 1. Right? It's the same as the graph that I just had. I'm just losing a little detail here just for brevity's sake. But the domain is 1 to infinity. And what's the range? The y seems to start at 0 and goes all the way up. Bracket 0, infinity. And as you might anticipate, what happens to the domain and range? They switch, right? The domain of one becomes the range of the other, which is anticipated for the inverse function. Very logical because you're just switching around the x and y, right? Switch around x and y. The domain of f is the same as the range of f inverse. And likewise, the range of f turns out to be the domain of the inverse. And it's because you're switching around every x and y value, as you might guess. Okay, 29. F of x equals 1 over 2x. You can graph it if you want to. 1 over 2x looks like this. It's an odd function, has origin symmetry, and so on. Okay, so find the inverse. Call this y. Y equals 1 over 2x. Switch around x and y. So if I switch around x and y, put an x there, put a y there, it looks like this. X equals 1 over 2y. All right, then I don't like the fraction, so I multiply both sides by 2y. 2y times that, 2y times that. So these cancel out, just give me 1. So I have 2xy equals 1. Solve for y. Divide both sides by 2x. So y equals f inverse of x equals 1 over 2x. So here's my inverse function. And you may notice, how does that compare with the original thing that I had? Same thing. So again, 1 over 2x is its own inverse. The inverse of 1 over 2x is itself. So if I talk about graph f and its inverse, well, if you already graph f, you already have its inverse. Okay. So what I'm trying to illustrate there, I think I have green and red. So in red is the original f. In green is the f inverse. I just superimpose one on the other, meaning it's the same graph. So it's allowed for a function to be its own inverse. And if I do the reflection game, right, it does look like the reflection across the line y equals x of this part is this, and the reflection of this is this, and so on. So yes, a function is allowed to be its own inverse. All right, so I think that's about all I had for 2.5, which means I'm pretty much done with the chapter, folks. I can go back and do my own review of questions that people had earlier from other sections, but maybe I'll start off with this. Does anybody else want me to do something from 2.5 right now? Okay, before I do that. So yeah, technically, I'm done. So I should have given you enough information for everything you need for the test on
Could
Friday.
we go over 37 one more time? I'd like to see how you got the inverse, because I'm not seeming to be getting the right inverse, and I'm not sure why.
Okay. All right. So looks like I've finished everything I need for chapter 2, and we should be good for that. Okay, so back to 37, was it?
Yes, please.
37. Okay, the key for that is to realize that the absolute value of 2 minus x is the same as the absolute value of x minus 2. You don't actually have to do that, but it makes the problem easier. Okay, so let me go back and run. Okay, so absolute value of 2 minus x is the same as the absolute value of x minus 2. So I claim these two are equal.
Okay.
It's because 2 minus x is the opposite of x minus 2. Right? You can distribute that out, negative x plus 2, same thing. So have the same absolute values.
Then why isn't it negative x plus? Wait, I'm confused. Here.
You could, in other words, if you want to think of it like this.
Oh, I see. Yeah, it's
Fine.
the same thing as negative x plus 2.
It's going to be the same as absolute value of x minus 2, right? Okay. So if something and its opposite will always have the same absolute value, 7 and negative 7.
But your equation isn't negative x plus 2. Like that's what I was doing, and it's x minus 2.
Yeah, these two equations, these two are the equal.
Oh, I guess right. Damn it, I see it. Okay.
Now, if you're not convinced of that, plug in the number like 3. What do you get when you plug in 3 here? Negative 1, right?
I
plug in
see
3
it.
here,
Yeah.
you get positive 1, but they have the same absolute value. Plug in 10. 10 minus 2, 8. 2 minus 10, negative 8. They have the same absolute value.
So would the inverse just be x minus 2?
The inverse here looks like
or
it's
x plus 2?
X plus 2, yeah.
Or x minus 2. We could do either side, right? We can do for the restricted domain, we could do either side.
We could do either side, correct. But it's like, why do you want to do the negative when you could do the positive, so to speak? So this would have been negative x plus 2. You technically could do that, but we would normally prefer this side, the positive side. Okay. All right, I see something in the chat. It's been 29. Okay. From 29. Find the inverse, right? So call it y. To find the inverse, you switch around x and y. So right here put x, right here put y. X equals 1 over 2y. Solve for y. I don't like the fraction, so multiply both sides by 2y. So I can cancel that out, that becomes 1, right? So 2xy equals 1. Solve for y by dividing by 2x. So y equals f inverse of x is 1 over 2x. So here's the inverse. And it happens to be the same as the original. Okay, and by the way, in terms of a quick graph, I know this is 1/2 of 1 over x. So you should be somewhat familiar with 1 over x. It's going to be a vertical compression. Squinches it down a little bit, but it still has the same general shape. Okay, and then 35, x squared plus 1, x is greater than or equal to 0. Right, so I know this is a parabola opening up, which will not be 1-to-1 unless I restrict the domain. They did restrict the domain. They said x is greater than or equal to 0. Now it's going to be 1-to-1. So you can plot points like I did, or again, switch around x and y, x equals y squared plus 1, solve for y. So I subtracted 1, x minus 1 equals y squared, take the square root. So y equals f inverse of x equals radical x minus 1. And I don't need plus or minus because I already have the restricted domain. I know I'm going to be in the first quadrant. Okay, and what is this? This is my basic square root function shifted 1 to the right. So there it is. Okay. All right, let's see. 39, the very last problem. And that one's going to be completing the square. So let me show you how that one's going to work. There's some space here. $2.539. So first I'm going to complete the square. Half of -2 is -1. -1 squared is 1. So I'm going to go +1 minus 1. Which now factors into x minus 1 squared minus 1. So I take my standard y equals x squared, and the vertex got translated, let's see, 1 to the right, 1 down. So your standard parabola, y equals x squared, looks like this, right? But the vertex is 1, -1, 1, -1. So it's supposed to be this. And we know it's not 1-to-1. We would not pass the horizontal line test. But if I restrict the domain, and the way you normally want to do this is start from the vertex and then keep the stuff on the right. If you keep the stuff on the left, there's more problems with it, and you'll end up with doing a negative for square roots, possibly. So this is what I want. So f of x equals x squared minus 2x, where x is greater than or equal to 1. Now it's 1-to-1. Right, so let's see. So the given function is not 1-to-1. Determine a subset of the domain of the function in which it is 1-to-1 and find the inverse in the restricted domain. Okay, so now how do I find the inverse? Y equals x squared minus 2x. Find the inverse. Well, switch around x and y. Well, I'll complete the square again. It's the same algebra as this, right? It's going to be +1 minus 1. Solve for y. So how do I solve for y? Add 1. How do I get rid of the square? Square root. And add 1. Aha. This is my square root function. Moved 1 to the left and 1 up. So -1, 1. So -1, 1 is here. And I draw my square root function. And it's something like this. Here's my f inverse. Square root of x plus 1 plus 1. This is 1, -1. This is -1, 1. And yes, it does look like one is a reflection of the other across a line y equals x. And maybe just to show you that, I'll put a dotted line on y equals x to illustrate that. Okay. There's a line of reflection right here. Okay. All right, I've got nothing else, folks. So I'll let you ask questions, and if you don't have any questions, we'll stop, we'll adjourn, and then tomorrow I can let you ask questions on anything, but I'll probably give my own review questions. But if that stops, I might just go ahead and sneak in some of chapter 3. Okay, so Friday's a test. I am finished with what needs to be done. So buffer day doesn't mean holiday. Tomorrow's not a holiday. So we still meet. So if you want to ask any questions on chapter 2 tomorrow, you may. I have my own review questions from some people who've asked in the past, so I'll do all those. And if nothing else happens, then we'll just sneak in some of chapter 3 perhaps. Okay, any other questions, please? About anything? Let me check the chat here. Stop the share. Okay, so anything else? If not, then we're going to call it a day. All right, that'll do it for today, folks. So if you want to ask me any questions on chapter 2 tomorrow, you may bring them up. I'll do my own review and be ready for the test on Friday. Okay, that'll do it for today, folks. So have a good day, and we'll see you next time.
Professor, you too.
Okay. All right, bye-bye.
Bye.